Life cycle of a star. Nebula is a cloud of gas and dust in space. The nebula is the birthplaces of stars. There are two different types of nebula. Planetary nebula, outer layers of a star that are lost when the star changes from a red giant to a white dwarf. An emission nebula which glows brightly because the gas in the emission nebula is energized by the stars that have already formed within it. A star can produce its own heat and light by nuclear reactions, which is also known as nuclear fusions. Stars are born from nebulae and they consist mainly of hydrogen and helium gas. The surface temp of a star can range from 2000 Celsius to above 30,000 Celsius. The colours can vary from red to blue to white. The brightest stars have masses more than 100 times of the Sun and can emit as much light as 1 million suns. Stars can live for 1 million years before becoming a supernova. The smallest mass for a star is about 8% of the Sun. Towards the end of a star, like the Sun, swells up into a red giant before losing its outer layers as a planetary nebula and finally becomes a white dwarf. Red giant is a large bright star with a cool surface. Red giants have diameter between 10 and 100 of the Sun. Red giants are very bright because of its size, although their surface temp is lower than the Sun, about 2000 to 3000 Celsius. Red dwarfs are very faint small stars. Red dwarf is about 1/10 of the mass and diameter of the Sun. Therefore, lifetime is about 100 billion years. White dwarf is a small hot star. White dwarf's mass is similar to the Sun. The surface temp is 8000 Celsius or more. White dwarfs are the remains of a normal star, which the nuclear energy have been used up. White dwarfs cool and fade over several billion years. Supernova is the death of a star. Supernova is the brightest of 100 million stars for a short period of time. There are two types of supernova. Number one, these occur in binary star systems in which gas from one star falls onto a white dwarf. Number two, internal nuclear reactions at the end of their lives leading to an explosion. They leave behind neutron stars and black holes. Neutron stars are produced when a supernova explodes and contains mainly of neutrons. When a supernova explodes, it forces the protons and electrons to combine to produce a neutron star. Black holes are formed when massive stars at the end of their lifetime. The gravitational pull in the black hole is so great that nothing can escape from it, not even light. The density of it cannot be measured. Life on Earth. Earth is about 4.5 billion years old. The earliest evidence of life on Earth comes from the fossilized mats of cyanobacteria, called stromatolites, in Australia. They are around 3.4 billion years old. These bacteria are biological complex. They have cell walls protecting their protein, producing DNA. Scientists think life began much earlier, maybe even as 3.8 billion years ago. The fossil that is related to the first humanity on Earth was an Ardipithecus ramidus. There were 35 members of a species that were discovered in Ethiopia and are roughly 4.4 million years old. Ardipithecus is the first creature on our side of the family tree. The Ardipithecus ramidus was the first reported in 1994. They discovered and realised the skeleton reflects on a human African ape. There were little difference in size between males and females. The Ardipithecus ramidus fossils were found alongside frontal remains, meaning she lived in a wooded environment. This challenges the savanna theory for the origin of bipedalism, which states that humans learned to walk upright as climates became drier and environments became more open and grassy.
Galaxies in our universe. The Milky Way. After the Big Bang, the universe was made up of radiation and subatomic particles. There are two different scenarios that could have happened to create the Milky Way. The particles could have formed stars, then clusters of stars that could have eventually formed galaxies, or did the universe create clumps of matter that eventually subdivided into galaxies? The Milky Way is a spiral and is made up of at least 100 billion stars as well as dust and gas. The shape of a galaxy depends on its neighbors. It may collide into other galaxies, defining its shape. The Milky Way is on its own collision course into its closest neighbor, the Andromeda Galaxy. Evidence states that the galaxies are the same age, but Hubble's observations suggest that the stars in the halo of Andromeda are much younger than the stars in the Milky Way. From this, it suggests that the Andromeda has already collided into at least one or maybe multiple galaxies. The Andromeda is a spiral galaxy that is made up of about 1 trillion stars and is the closest galaxy to our Milky Way. Even though the Milky Way has more mass, the Andromeda is bigger than the Milky Way and 2.5 million light years away from our Earth. Like the Milky Way, the Andromeda can be seen from the naked eye. The Earth is predicted to be 4.45 billion years old according to geologists who use radiometric dating system. The Earth is the third closest planet to the Sun and is very different to every other planet in our solar system. There are many things that make our Earth unique. We are the only planet in our solar system that has life and are the only planet that has water on the surface. The Moon is 4.5 billion years old. It travels counterclockwise around the Moon and takes around 27 days to orbit the Earth once. The Moon pushes and pulls the water with the gravitational pull. The Moon gravitational pull is the strongest on the side that faces the Earth.
The Big Bang Theory is a way to explain how our universe began and what happened at the beginning before anything else. This theory expects that the universe came into being around 3.7 billion years ago. When most people think of the Big Bang, they think of an explosion, but there was no explosion, it was an expansion. Before the Big Bang Theory, the universe was theoretically nothing, and the Big Bang suggests that it expanded to become our universe. Evidence suggests that it is still expanding today.
The Sun is about 4.6 billion years old and is a yellow star. It's so big that our Earth can fit inside it about 1 million times. The Sun gives our Earth life. Without the Sun, there would be no life on Earth. The Sun has 6 layers: the core, the radiative zone, convection zone, photosphere, chromosphere, and the corona.